Hello everyone, my name is Khushboo. So today we are going to start a topic which is reader-writer problem, introduction and reader's preference solution. Basically, it is a topic of operating system. So in this video, we are going to cover these topics, which is what is reader-writer problem, solution of reader-writer problem, writer's process, reader's process and so on. So what is reader-writer problem? Reader-writer problem is a classical problem of process synchronization. It relates to a data set such as a file that is shared between more than one process at a time. Among these various processes, some are readers, which can only read the data set, they do not perform any updates. Some are writer, can both read and write in a data set. So let's understand with an example. If two or more than two readers want to access the file at a point in time, there will be no problem. However, in other situations like when two writers or one reader and one writer wants to access the file at the same point of time, there may occur some problem. Hence, the task is to design the code in such a manner that if one reader is reading, then no writer is allowed to update at the same point of time. Similarly, if one writer is writing, no reader is allowed to read the file at that point of time, and if one writer is updating the file, other writers should not be allowed to update the file at the same point of time. However, multiple readers can access the object at the same time. So let's understand the possibility of reading and writing with the table given below. Solution of reader-writer problem. The solution of reader and writer can be implemented by using binary semaphores. We use two binary semaphores, write and mutex, where binary semaphores can be defined as a semaphore is an integer variable in S that apart from initialization is accessed by only two standard atomic operations. So, solution when reader has a priority override. Here priority means no reader should wait if the share is currently open from reading. Their variable are used, mutex, write, read, implement, so on. And writer process. Writer requests the entry to critical section. If allowed, that is, wait give a true value, it enters and perform the write. If not allowed, it keep on waiting. It exits the critical section. And reader process. Reader requests the entry to critical section. If allowed, it increments the count of number of reader inside the critical section. If this reader is the first reader entering, it locks the write semaphore to restrict the entry of writer if any reader is inside. It then signals mutex as many other readers is allowed to enter while others are already reading. After performing reading, it exits the critical section. When exiting, it checks if no more reader is inside. It signals the semaphore right as now. Writer can enter the critical section. If not allowed, it keep on waiting. Thus, the semaphore write is skewed on both reader and writer in a manner such that preference is given to reader if writer are also there. Thus, no reader is waiting simply because the writer has requested to enter a critical section. So yeah, that's all about our topic. So you can test your understanding by go through this question. And these are some references. Thank you very much.